Threat modeling is basically, it's a process to understand the threats against an application, right? So I should probably define what exactly a threat is. A threat is really just an attack goal that an adversary has with respect to any given system. So threat modeling is, one of the reasons why you do threat modeling is really to understand the attack surface for an application, understand what an adversary really wants to do with respect to a specific instance, or a specific system. So based on that, the idea is that once you've enumerated this threat profile, you understand what an adversary wants to do, and so you can employ appropriate countermeasures, whether whether they relate to security design or secure implementation practices. The reason why is really, I mean, if you're going to implement something securely, you really have to know what you're going up against, right? So if you don't really understand what you're going up against, then you can add security features, but they may not even be directed towards the right threats or the most relevant threats. So the idea is to understand understand the playground, if you will, first before really doing design and implementation. So
cool. So what are you going to show us today?
So we have a public version of the threat modeling tool, that's available on the Microsoft website. We made that available recently, and I'm going to open up. I'll open up the threat model that actually comes as a sample with the tool. Now, this is actually, if you do download the tool, you can get this threat model from. It's actually just in the program directory for the threat modeling tool. And it's a threat model for a fictitious telephone. This telephone is pretty much like any other arbitrary telephone that you've seen. It's got a built-in answering machine, the ability to retrieve your messages and phone configuration remotely, which is again common to most answering machine telephones. It's also got a couple of additional features, like for instance, it's got the ability to lock out the use of the phone, so that if somebody wants to call long distance, they have to enter in a passcode before they can do that. So this is an example of a threat model, and since it's relatively abstract in that it's a threat model for a telephone, it's not a software system, so it's really designed just to describe some of the concepts behind threat modeling, and not be specific to any one technology. So the threat modeling tool is relatively simple to use. It's organized on the left you have your navigation pane, and on the right you have all your data here. On the left you can see that we've got 3 high-level categories: background information, entry points and assets, and threats. Each one of these high-level categories is broken down into lower-level categories. So you can see we have use scenarios, external dependencies, and etc. And each of these has has individual items, and on the right, whenever you click on it, you can see that you get an editor for that specific data type. So you can see that, for example, the editor for the threats significantly different than what you see for use scenarios. So getting started with the tool basically is relatively simple. If you've taken a look at some of the threat modeling resources that we have online, it parallels a lot of that methodology, and in fact, it's actually based on the methodology that we describe in the threat modeling book that we actually just recently published. So it goes along with that relatively well. And in fact, the Fabricam phone sample is the same as the sample in the book. So threat modeling is again, like I said, it's a process of understanding the threats against any given application. The steps to doing that are parallel again in the tool. The first one is describing background information. We do that because we really want to scope the discussion and make sure that we don't start talking about things that are outside the bounds of that particular threat model. So, for example, we collect data on use scenarios, so how the system is intended to be used or how it's not intended to be used. So, for example, some deployment scenarios that would be considered unsupported because of because we can't support security in this particular configuration or something like that. So that's one bit of relevant information. Other things that we collect here are things like external dependencies. External dependencies one of the problems in security is that, or a place that vulnerabilities often creep up is when systems are integrated together or at component boundaries. So external dependencies really serve to document these inter-component dependencies or inter-system dependencies, so that we can say that these sorts of things have to be verified before we know that the system is going to be secure. And the canonical example that I always give here is path normalization, right? So if you're writing, for example, you're writing a web server gets passed in the request, it gets passed a resource path. The web server has to do a certain amount of normalization on that path before it can decide what information to serve to the end user, whether to pass it through the scripting engine or just serve it as plain text or whatever. But when that path is prepended with the web root and gets passed to the file system may also do normalization on that path, right? So there's an implicit external dependency on some web server with respect to the file system, and that the normalization routines have to be the same. If they're not the same, then the web server may think it's giving access to one resource, but the file system may actually open up something else. An example of this is actually there were vulnerabilities in older versions of IIS that would allow you to escape out of the web root using various Unicode encoding and things like that. So,
right. How does Microsoft use your tool?
We use it actually as part of our security development lifecycle. It's really used to again, like I said, to collect all the information into a easier to use format. It's actually been adopted by quite a few teams at Microsoft, and it is the recommended method of collecting the data. So.
For a developer who's new to threat modeling,
Mm-hmm.
What would be the 3 tips that you give them when they're using your tool?
Well, so there's a few things. Let's see. First of all, the most relevant, and I probably should have started with this because we're time limited, but the most relevant things that I want to point out are that are, first of all, entry points and assets. There's 2 really important things here. The entry points, because entry points describe, they're really the points where data or commands transfer between the system being modeled and the outside world. So entry points are inherently the locations where an adversary can attack the application. So they're things like sockets and RPC endpoints and interfaces and data from the file system. Whatever the case may be, these are the places where somebody can attack the application. So those are very important to note in the threat modeling tool. The other thing here is protected resources, or also called assets in the book, but as well as elsewhere. Assets are the whole reason why somebody attacks the application in the first place. So they are, it can be something concrete like data in a database that somebody wants to retrieve, or
credit card numbers.
Exactly, credit card numbers. Or they can be something a little bit more abstract. For example, the example that I often give here is network coherency in a peer-to-peer network. Somebody can break up the network into a bunch of disjoint graphs, then they've caused a denial of service for the peer-to-peer network. So assets are things that somebody tries to affect in some way. And then based on those really form the basis of threats. And threats, an important thing to note here is that threats are not vulnerabilities. They're really adversary goals. They're something that an adversary wants to do with respect to an asset. So you can see that in the threat modeling tool, all threats are cross-referenced with protected resources, or again, like I said, assets. The reason why this is, again, is because you can't have a threat unless you have an asset. You have to have a target of the threat, right? So if you aren't targeting anything, there isn't a legitimate threat there. So based on all of the different assets that the system has, you can enumerate the different threats. Somebody may want to, for example, the example of corporate data, somebody may want to retrieve that information, or they may want to change that information. There's different goals that they have with respect to any given asset. And threats are abstract in that they just state what that goal is. So from there, the next real step is to go and investigate the threat to determine whether or not the system is actually vulnerable to it. And that can be done using various methods. One of the important methods that the tool supports is the concept of threat trees. These are also called attack trees in in different texts. But basically, the idea is to take this adversary goal and break it down into lower level conditions. And those lower level conditions are just basically steps, if you will, that have to be true in order for an adversary to achieve those goals. So the threat modeling tool has this built-in threat tree editor that basically is this tree view of the breakdown of the threat into its into the required conditions that have to be true to exploit it or to achieve that goal. So you can view it as a graphic, or you can view it as a textual representation, but it's a relatively useful tool for decomposing a threat into into required steps. Now, again, like I said, pardon me, a threat is just a goal, right? It's not a vulnerability, but a vulnerability is a specific method of achieving that goal, right? So that fits in relatively well, especially with the threat trees, in that, like I said, a threat tree is a way of decomposing the threat into conditions that have to be true for it to be realized. Well, a vulnerability is in essence, if you're defining it in terms of a threat tree, it's a specific attack path in that, specifically a valid attack path in that threat tree. And when I say an attack path, what that means is you starting at any given leaf node, you traverse up to the root threat. If you get all the way up to the root threat without hitting a mitigated condition, that means that there are no all the conditions that have to be true for that threat to be realized are unmitigated, and so they can be achieved. So a vulnerability in the case when it's with respect to threat trees is really defined in terms of an attack path. And since for any given threat tree there may be multiple attack paths, you can have multiple vulnerabilities associated with any given threat, which further makes sense because if we're defining threats as simply as attack or attack goals of an adversary, there may be more than one way of achieving that goal. So that's why in the tool you'll see that in the threat editor you can see that there's down at the bottom there's a list of vulnerabilities that are associated with any given threat. Again, like I said, because there can be 0 or more vulnerabilities associated with a threat. So we have that there. The tool, again, like I said, the tool is really just a method of organizing the threat model into all the relevant data points. And so it's got a lot of cross-referencing capability to like I said, reference things like assets and entry points with threats, stuff like that. But a few other things that I just want to cover really quickly here are that it does like you may have seen in writing secure code, or if you've gotten a hold of the threat modeling book or other text, data flow diagramming is relatively important in decomposing the system as a whole to understand how it works and where threats are going to crop up. So if you have Visio 11 installed, it uses basically the Visio 11 has a drawing control, and so it embeds that within the application. So you can go ahead and use Visio directly in the application to edit data flow diagrams. If you don't have Visio 11, it does have a relatively simple data flow diagram editor, but really the better way of editing is if you have Visio 11. So you can edit that directly in. It does store all of the data as XML. The .tmd document format really is just XML. So the report format is, well, the report, generating a report from the threat modeling tool is really just a matter of applying an XSLT to it. So there are two XSLTs that come with the threat modeling tool. There's one that shows the entire report, and then there's a second one that just does a simplified report that just shows threats, essentially. the XSLTs are stored in the installation directory. So if you want a custom report, it's relatively simple to go ahead and modify that. There is a preview. There's a report preview that will take whatever you've configured as the default XSLT and basically just render the. Let's not see that. That was an error. I apologize. Actually, one thing I should note is we have an internal version of the threat modeling tool and an external version, and my configuration is still for the internal one. But actually, let me just change it to this. The actions. Oops. Change the report preview here. See if that works. So when you've got it actually configured correctly, again, like I said, previously I had the internal version, so it basically had a different report template essentially that isn't installed as part of this. But the report preview just applies the XSLT to the threat model, so you can see that all the information in the threat model is presented in HTML. It includes all of the diagrams that are getting a little bit clipped because of my screen size at this point, but as well as graphical representations of the threat trees. The simplified report version actually prints out threat trees in textual form. So if you want, again, like I said, if you wanted to customize it, you could certainly do that. So that's basically how you generate a much more readable form of the threat modeling report. It turns out that, well, at least in my opinion, I think that the readable format versus the text entry format for threat models is different. I mean, I think that it's easier to view in HTML like that, but as far as entering the data, it's a lot easier to use a tool like this to organize it into the
Does threat modeling